Okay, we're going to look at trusses. It's a new topic. And what is a truss? Well, a truss is basically a structure made out of long, skinny members. It looks something like this. We have, what amounts to a bridge here. And you'll notice that we have made our bridge out of these long, skinny members. And the advantage of that is that we find that this is a very light structure because there's a lot of airspace. You see all the airspace there. So it's very light and very strong. And you'll notice everything's sort of a triangle here. We're putting together a bunch of triangles is what it comes down to. And when we do that, we can make a very strong structure. And we call it a truss. Now notice we're going to put loads on this truss. Each load, it has to be put at a node. We don't put any, because these members are long and skinny, we do not put any loads not at a node, because if we put a load not at a node, this is going to buckle. So loads must be at the nodes. Okay, but the trusses take many different shapes and sizes and things like that. So here's another one. We have a truss here, and we put various loads in various directions. Notice again, of course, they're always at a node. We can build a beam out of a truss. That's what we frequently do. So, if we make the truss long enough, etc., we can create an entire beam with a truss, as we've done here. Again, we're going to be concerned about taking moments, and so one of the big things is the line of action for each force. So we started preparing for that, and this is something that gets students confused, so we want to make sure we get it right. So here's our truss. Again, we want to find the reactions, down here at A and in this case E. So we've labeled each point, each node, A, B, C, D, E. So we're labeling them with letters, and we have our loads at nodes. In this particular case, all of our loads are vertical and horizontal. And then when we draw our free body diagram, we need to consider the line of action of each force. So we've got our free body diagram here, and this is a hinge. So what do I have? I've got an AX and an AY there. And this is a roller, so I have an EY. So all of those loads have lines of actions. So doing one at a time, the 8 kip load, there's its line of action. The 6 kip load, it's there. The 10 kip load, it's there. EY is there. AX is here, AY is here. So those are all the lines of actions. Quite straightforward. To draw the lines of actions of all those loads is quite simple, as you can see. Okay, so this is your homework. Draw the, free body diagram and draw the line of action for each force. Line of action for each force. Okay. So again, I've got my AX and my AY, and in this case CY, there. So my lines of action are the following. It's for the 3 kilonewton load, it's that. For the 6 kilonewton load, it's that. For the 8 kilonewton load, it's that. Now for the 4 kilonewton load, oh look, it's the same as the 3. Okay, that's all right. For the 10 kilonewton load, it's here. We have to draw these long for a reason, as we know, because we need to get the perpendicular distance. And for AY, it's that. For AX, it's the same as the 10 kilonewton load. So, again, very straightforward, but you have to draw. Notice how long I'm drawing these things. Oh, CY. CY is the same as the 8 kilonewton load. All right, let's skip that. You have to draw them long because we have to get the perpendicular distance, and it depends on what point we're taking moments about to get the perpendicular distance. So draw those long. Okay, so we're going to take moments about A, and we're going to find the moment arm for each force. Our goal is to find EY. So, I'm going to be taking moments about A. So when I take moments about A, to be honest with you, I don't really need AY and AX because they go through my point. So the distance is 0. So it doesn't come into my equation. So I want to find the moment arms. Well, the 8 kip load is like that. So what's the moment arm for the 8 kip load? Well, it's this distance. Right here, that distance right there. Because that's point A, the perpendicular distance for the 8 kip load is there. So I want this distance, which is 4 feet. My next load here, for the 6, there's the perpendicular distance right there. And then that means I'm interested in this distance, which is 3 feet. I want to know the perpendicular distance. So it's going to be 6 times 3. And then for the 10, again, this is the perpendicular distance. And that distance then, well, I guess I didn't show it exactly, but the way it's all set up, you can see that that distance is 1.5, that distance is 3. So the total distance here is 4.5. 10 times 4.5. And then if we look at, are they positive or negative? Again, what do I see? This one is going to be positive about or clockwise about 0.8, so it's positive. This one is going to be clockwise about 0.8, so it's positive. This one is going to be clockwise about point A, so it's positive. And I guess I didn't do EY. There's the line of action of EY. Well, EY, there's my moment arm, the distance, there's my moment arm, which has a distance of 6. And which way does it knock the hand? It knocks it counterclockwise, so it's minus. And then I can solve for EY. And I get EY is 13.2. Okay, so here's your homework. For taking moments about point A, get the moment arm, find the perpendicular distance, which is the moment arm, and do it for each force. Find CY. And then take moments about C to get AY. Take the sum of the forces in the x direction to get AX. And I guess I've already covered this, so. Okay. So pause the video here and solve this problem. All right, so we're going to take moments about A. Now here are my, we've done our, I've already sort of shown you the line of action of the forces. So, there it is for, whoops. There it is for the 3 and the 4. That's for both of them, right? They both go through that. Both have that same line of action. Here it is for the 6. Here it is for the 8. And this is also the 8 and the CY. So I'm taking moments about A. And so, there's my line of action for the 3. And what is the perpendicular? There's the perpendicular distance to that line of action. And it's 3. So 3 kilonewtons times 3. And it's positive because this is going clockwise. The 6, line of action for the 6, the distance is 2. And we can see that it also goes clockwise. So it's positive 6 times 2. The 8, the perpendicular distance is here. So it's going to be 8 times 7. And it's positive because, again, it's going to knock that hand clockwise. This may look trivial, but I guarantee you people make mistakes on this all the time. So pay attention to it. Here's my 4. It works along that line of action. It has this perpendicular distance, which is 3. And as I look at this, it's going to turn that hand like that, clockwise. So it's going to be positive 4 times 3. And then I've got my CY here. There's my perpendicular distance. It's going to knock it counterclockwise, so it's going to be minus CY times 7. And then we're going to notice this 10, what happens to it? It goes right through point A. So it's 10 times 0, or you just ignore it. So the line of action goes right through line A, so it's 10 times 0. I solve that for CY, I get 12.71. Now I'm going to take moments about C. I have to get my perpendicular distances. Well, here's one perpendicular distance, here's another perpendicular distance, here's another perpendicular distance. So all the perpendicular distances are shown. I'm taking moments about C. And what do I have? I've got, so I take one at a time. I've got the 3, I've got the 6, I've got the 8, I've got the 4, I've got the 10, I've got AY and AX. So I have, one way to look at this is when you're all done, you should have, 1, 2, 3, 4, 5, 6, 7 terms in the equation. So if I look at this, 1, 2, 3, 4, 5, 6, 7 terms in my equation. It's one way to check it. And then force times perpendicular distance. It's 3 times 3. Oh, sorry. Yeah, I'm correct here, but we got to pay attention to point C. 3 times 3. Take moments about C. I have this line of action, 6. What's the distance? It's 5, because there's my perpendicular distance. So it's minus 6 times 5. Now what do I see? This 8 goes right through point C. So it's 8 times 0. It just drops out. And then I've got the 4 that perpendicular distance is also 3, so it's going to do what? It's going to cause that direction, so it's clockwise, so it's going to be positive 4 times 3. The 10 goes through the point, so it's 10 times 0. The AX goes through the point, so it's AX times 0. And then I've got my AY, there's the line of action for AY. It's like that. The distance there is going to be 7. Again, it's going to be positive because it does clockwise. So it's going to be plus AY times 7. All that's equal to 0. We have them all solved for AY, and I get 1.29 kilonewtons. And then I can take the sum of the forces in the x direction equals 0. And I get that I have AX, I have AX, I have 3, I've got 4, and I've got 10. That's in the everything's in the positive to the right direction, so everything is positive in the equation. I solve for AX, I get AX is equal to negative 17. So my final free body diagram looks like this. 17 goes the other direction to the left. And we can do a double check. Does up equal down? So there's my up, which is 14. I've got 14 going down. I've got 17 to the left. I've got 3 plus 4 plus 10 to the right. 17 left, 17 right. So that's a check. I can also check by taking moments about point E. So I can take moments about point E. You can take a look at doing that. We have to do the same thing. We have to use the lines of action, and please double check that. But again, what we see in this particular case, we get 0.032 close enough to 0, or no, it's 0.03, close, approximately 0, so we say it's okay. A little bit of round off, but that's okay. Okay, so find these reactions. For this one, draw the final free body diagram. Find the reactions, draw the final. Notice, now I've got, my truss is coming off the wall here. So that means what? I don't have a BY, but I do have a BX. I do have an AX and an AY, because that's a hinge, but the B is just a BX because it's a roller in the vertical direction. Okay, find the reaction. So here's my free body diagram, and I need to, as you're starting to do these problems, what you should do is draw these lines of action of all the forces. So just to get it down, after a while, after you've done enough of these, you don't have to. But I want you to not make mistakes, and people get confused. If you don't understand the line of actions, you're going to get confused and make mistakes. So we just start out, we just look at all the forces here. So I just look at that, for instance, and what do I have? Well, I've got a line of action for forces there, got a line of action there, got a line of action there, got a line of action here, and I've got a line of action there. So all you have to do is look at all the forces. Now that you have all the lines of action, so I'm going to look up here now, then now, for instance, I can take moments about point A, and I now, since I see the lines of action of all these forces, then, I can go one at a time. Well, that's going to be 5 times, 8 for that one, and this will be 15 times 5. And then I've got, the 4 over here, so it's going to be 4 times 6. And a bx times 6. Now, what are the signs here? So the bx is going to, send things around like that. So it's negative. The 15 is going to send things like that. So it's clockwise, so it's positive. And this 4 and the bx, for that matter, they're both going to be negative because they send things around counterclockwise, both the 4 and the bx. So that's all reflected here. And I solve for bx, I get 15.17. Take moments about b. Here I am. And I have my perpendicular distances about point B. And there's one. There's one. There's one. So I'm going to let you look at these and justify where these forces are and what's positive, what's negative. I get AX is equal to negative 37.17. So I follow the same rules that I've been doing. Because it's negative, I got to flip the arrow around. Also, I take some of the forces in the y direction now because I want to get AY. And I have in the y direction, I've got the 15, and I've got the 5 here. 15 and 5 are both going down, so they're negative. And I'm showing a y is going down, so that's also negative. Again, I chose that when I drew the free body diagram. It's okay, as long as I show it negative AY here. And so I solve for AY and I get negative 20 kilonewtons. There's my final free body diagram. Okay, so do this problem. This is really homework, so I should say homework here. Again, what you should do is draw the lines of action as you need. Draw the free body diagram. Notice that I've got a roller here, I've got a pin there, and you need, at the pin, of course, I'm going to have an AY and an AX. At point B, though, I just have, a BX. Why? Because it's, it's a roller, and as we know, rollers only act in one direction, and in this case, it's the X direction. Okay, so hopefully you've done this problem. Again, you got to draw the lines of action. So the easiest way to do it is just look at all those forces and just start drawing lines in the directions of these forces, and you've got all your lines of action. Just look at a force, draw a line of action. A lot of times you're going to look at a force and it's already got the line of action there because it's already had a force in that direction. So, but we have to get it right. And so I start with taking moments about A here. And what do I find? Well, a number of forces sort of drop out. This force goes, that one goes through, and that one goes through. So which forces do I eliminate? Well, that 8 kips doesn't matter. That 6 kips doesn't matter. And this 5 kips doesn't matter. So we can get rid of a lot of these forces here. We don't have to put them into our equation because it's 0. Because the moment arm is 0. So then I just leave the ones that I have, which are the 9, 3, the BX, and then the 12. Everything else goes through the point, and so we get, for the sum of the moments about A, 9, it's going this way clockwise, so it's going to be 9 times 12. And the 3 times that distance, which is 8. And the BX times this distance, which is 5, goes negative. And we have the 12 times that distance, which is 6. So then we can get the BX is 40.8. Similarly, I'm not going to go through everything. I'm taking moments about C. Now, I get that even label what C was. Yeah, I did. Okay, so I guess I didn't. Did I label these things? I guess I didn't label the points. Okay, but no matter. When I created a point C here, so I can take moments. I can take, like I said, we can take moments about any point. Why did I choose to take moments about point C? Well, if I want to find AX, it's a good one because why? Because the line of action of BX is through there. The line of action of AY is through there. And so that means that the moment arm is 0 for those two forces, and the only unknown left is the AX. So you have to, it's helpful to look at these things and figure out, what's the best point to take moments about. And sometimes it's not the obvious ones that we've been doing. So I did this one deliberately to show that the BX and the AY intersect at a point way out in here. Well, the trick is to get rid of the unknowns. I just got rid of 2 unknowns. I got rid of AY and BX by choosing that point. So the point at which you take moments is going to work in your favor if you choose it correctly. You've got to choose a point that eliminates unknowns. So taking moments about this point C, is that taking moments about that point, what do I find? Well, again, I have 9 times that distance, which is 7. And I have this 3. There's my line of action. There's my perpendicular distance, which is 3. And then I have this 5. There's the line of action. It's going to go counterclockwise, so it's going to be minus 5 times 5. And we've got this 12 times this distance, which is 6. And then we have the AX times this distance, which is 5. And you have to be true to your figure. This sends the hand around counterclockwise. I solve for AX, I get 23.8. And then if we take the sum of the forces in the Y direction, we can get AY. In the Y direction, we have what? We've got the 8, the 12, the 6. And we put those into our equation. So down for 8, down for 12, up for 6. So minus minus positive there. Solve for AY, we get 14 kips. So we now have, and then take some of the force in the Y direction. Yeah, 14 kips. Yeah, so what do we have? We have, there are my unknown forces. This is my final free body diagram. Yeah. All right, I'm going to stop there.